Okay, I made a careless error here. I didn't put the transpose on this A. Now, obviously, when we multiply through by A transpose, we get an A transpose here, and, of course, down here. So be sure that you're aware of that error. Now, as promised, let's say we have 3 data points, and we want to, of course, we know we can get a perfect quadratic model for these 3 points. But let's say we just want a linear model. Let's say that this is something we don't expect to be quadratic. We expect it to be linear. And we want to see what the best linear model we can get might be. Well, we can write down our equations if we write down the form that we want to use for our linear equation. So I'm going to let y equal a plus bt. Then plugging in 6, 9, and 12 for y, respectively. When we plug in 4, 10, and 13 for t, we get these 3 equations that very clearly give us this matrix equation. Okay, and this, of course, is an equation of the form ax equals b. Now, in other videos, I've gone into some detail about depicting the subspaces and so forth, because everything here occurs in R2 or R3, and we can actually kind of draw the picture. And we can, we can draw the picture of the planes and the lines and so forth that are involved. So we can more geometrically depict the row spaces and null spaces that are involved in the solution. But without going into all that detail, and I recommend that you try to work this through, go through the details of the derivation and the picture, and why this equation holds. We get this matrix equation, okay? And of course, this isn't a square matrix, so we can't invert it and so forth. And we don't get a solution for A and B. We have 3 equations and 2 unknowns. Okay, it's not going to work out. So we try to get the closest solution we can as before, and by the whole argument we have given, this is the equation we end up having to solve, where x is this vector and b is this vector. Well, that's actually very easy to solve. A transpose A, well, here's A, it's here, and here's our x vector, and here's our A transpose. Just switch the rows and columns. Multiply this by this. Well, okay, this is the left-hand side. If we multiply these out, we get this matrix here. But we have the equal sign on the other side of the equal. We have the A transpose B. I discovered that I'd left this off when I tried to write A, B. This matrix times this doesn't work. We only have 2 numbers in the row, 3 numbers in the column. And what in the world's going on? Oh, duh. So it's prompted to make the error announcement here. Okay, so anyhow, the A transpose times B is here. And then A times A transpose is this. And A transpose times the B vector gives us this. I'm not sure I've got all the numbers right. Did them in my head. They're fairly easy, so I might have them right. Check me on that. So we have this matrix equation, okay? Well, that matrix equation is easily not found because it's pretty easy to invert this matrix because it's a 2 by 2 matrix. And, switch these, make these negative, and divide by the determinant. Or we could write out equations. 3a plus 27b equals 27. 27a plus 285b equals 270. And then, I would subtract 9 times this row from this row, or add negative 9 times this row to this row. That would eliminate A, and we get our solution for B. Okay, that would not be difficult. As a matter of fact, okay, you can stop here if you want to do it yourself. It's no big deal. But let's see how it works out. Okay, so I would get negative 27A plus 9 times 27 is 9 times 30, which is 270, minus 21, which is 249b, and I've got to be careful, I wrote down a plus, but I'm multiplying by minus 9. And that's going to equal negative 249. And then we have 27a plus 285b equals 270. I might be blocking the camera, but there's not much I can do from this angle. You know, this minus this is 36. And this minus this is 21. So b equals 21 over 36, which reduces to 7/12. Okay, now what is that? Well, that's the slope of our linear function. The slope appears to be 7/12. Yeah. Okay, now I'm not sure that fits well because the difference here is 9, the difference here is 6. Well, yeah, that would give you a slope just from this point to this point. The slope would be 6/9, 2/3. 2/3 would be 8/12. And I think I should get more 12ths than that. So you could work that out. But then we could plug this back in here and get A, right? For B here. And I don't want to work that out, but we're going to get 3A plus 27 times 7/12 equals 27. Multiply everything by 12. Do the arithmetic. Okay? Easy enough to do, but you can do it yourself. I don't want to continue because I'm not, that doesn't seem to fit for me because if anything, no, actually, this point is a little low for the line from here to here, from this point to this point. And this slope is a little low, so that works. So actually, I'm fairly confident once more. And, oh, what the heck, I'm curious now. So let's see, multiply by 12, I get 36a. 27 times 7 is 140, and 49, 189. And 12 times 27 is 270, 54, 324. If that's correct, subtract that, I get 124, 135. 36a is 135. A is then 135 over 36. And that's a little less than 144. 144 would be 4 times 36. It's about 9 less, so it's 3.75. Okay? So the equation might be y equals 3.75a plus, at 3.75 plus 7/12 t. Okay, that's all there is to it. Now, you probably don't want to do the arithmetic in your head. It's probably a good idea, because I've probably made a mistake someplace. But you can check against it. This is a plausible solution. I mean, I can visualize this graph. I see that, yeah, it's perfectly plausible that it should cross the y-axis around 3.75 and so forth. So you could plot those points and see if that seems to fit. You could plug t equals 4, 10, and 13 into this and find, you know, how close you are to these numbers, how close that gives you, how close that brings you to the correct y values, I mean to the observed y values, and this could well be your best fit straight line.